Complete the proof. Here we are given segment AD bisects segment BE, and that segment BE bisects segment AD. So these two diagonal segments bisect each other. And we're going to prove based on that the triangle ABC is congruent to triangle DEC. And notice that the A and the D are the first letters, so those are corresponding vertices, and that means the congruence is diagonal. Okay, the first given, segment AD bisects segment BE. And then the second statement is also a given, and that would be the other bisector statement. Now, based on those two statements, we need to make a conclusion for step 3. And when segments bisect each other, well, the segments that are bisected have equal measures. So in other words, right here, AC has to equal DC, and BC has to equal EC. And the reason for that is the definition of a segment bisector. Now the next statement, what can we conclude given that these segments have the same measure? Well, we can conclude that they are congruent. So there's the next statement, segment AC congruent to segment DC, and segment BC congruent to segment EC. And the reason why is the definition of congruent segments. And the reason why we're proving these segments are congruent is we're trying to prove that the triangles are congruent. So we're getting some corresponding congruent parts here. Next thing we can conclude is based on the picture. Notice we have a vertical angle situation here. So angle ACB is congruent to angle DCE. And the reason why is vertical angles are congruent. So our final statement is that triangle ABC is congruent to triangle DEC, and the reason why is the side angle side congruence theorem. And notice that we have segment AC and BC and the included angle ACB. Same deal on the other side, we have segment DC, segment EC, and the included angle DCE. So side angle side congruence theorem. So there is the completed proof.